I think we're live. I've only got one viewer. Hey Trevor. I'll type hey. Two people. One person. Alright, well, this is going to be quite long, so pretty much what I'm going to do, I'm just basically going to sit here and work through the NESA sample exam. I'll be honest, I haven't actually looked at it. I do have the solutions in front of me, but I have not looked at them, so it'll be kind of interesting. A couple of things I want to point out. This is supposed to take 3 hours. I'm curious whether it's going to take me 3 hours, because I do want to kind of talk through stuff, but I also want to give you an accurate representation of how fast you kind of need to go to finish this within 3 hours. So yeah, I don't know. I have no idea how long this is going to take. It could take 2.5, it could take 3.5, who knows. But you can just come in and say hi. If you've got any questions, just message me. I'll try and look up as much as possible. But basically, I'm just going to sit here and work through a paper for the next couple of hours. Yeah, now there's none of this in the top of my head stuff. It's going to be all on the paper. I've got my calculator. I'm not just going to read off the screen, hopefully, but yeah. All right, suppose we should, let me put the solutions up just in case. Oh, maybe I should put a timer up. What is the time now? It's 2:08. I do want to be able to see how many viewers there are. Looks like it's just Trevor. Alright. 2 minutes in, I haven't done anything. Okay, 2:08. So I want to be finished by 2:08 to who knows. Also, I haven't looked at the advanced content in a little while, so this should be interesting. Alright. Get messages. Still one viewer. I guess it's technically not time yet. We do start. The bell does ring at 2:10. Okay. What type of relation is shown? Well, I've got one thing going to many. Oh no. Okay. It's not 1 to 1. It's not many to many. It's confusing me because the answers say it's D, but isn't it 1 to many? I'm gonna skip that for a sec. Good start. Okay. At which point on this curve are the first and second derivatives both negative? Okay, so y dash is negative gradient. Y double dash is concave, so concave down, which means it looks like that. Alright, A can't be that because that's got a positive gradient. That's also got a positive gradient, so that means it's either this or this. At C, that's concave up. At this, that's concave down, so it's B. What's the gradient of any line perpendicular to this? Alright, I'll put it in gradient intercept form. 3 minus 3x. 1, 2 minus 3, 1, 2x. That's my gradient. So that's that. I must have the wrong answers. My solutions say it's A. Oh, perpendicular. Easy mistake. So that means 2/3. Sweet. See, I make mistakes too. Hi, Rico. Okay, what's a derivative of this? Oh no. I need my reference sheet. Damn it, I don't have a reference sheet. It's... oh no. A? to the power of f of x. Derivative is, damn it, is it log a f, is that it? Damn, I can't remember. It's definitely on your reference sheet. Do I then times by the derivative? This is a fail. Let's get a reference sheet up. Maybe I've got one here. That's the reference sheet. There it is. It's ln a. I was close. It's an f dash in there. Thank you. Really, Rico? Why do you have to dab? Alright, that's ln 5. Derivative is 2. And then, okay, so it's this one. I hate Pareto charts. A school collected data on the reasons given. What students? Oh, I put this on your. I put this on something. This looks familiar. Didn't I put this on the last exam? I'm sure I did. Was it the same? Yeah, train or bus delay. I'm sure it was the same. Anyway. What percentage of students gave the reason train or bus delay? Okay, train or bus delay, that's here. This is the percentage. Train or bus delay. Oops. Oh, what am I doing? It's not even a Pareto chart, is it? This, oh, it is. Oh, it's just 30. No. I'm so confused. What percentage of students gave the reason train or bus delay? It's purely of percent. So isn't it? That's the number. Yeah, so how is the answer 30? 5 is C. Don't agree with that. BRB. Alright. What are the values of x for which that equals 4? Positive, negative. Alright, two cases, absolute value. A good technique here might be to just substitute. That's probably faster, to be honest, because they're all the same. I'd substitute. Let's work this out properly though. So that's 3 minus 4x equals 4. That's minus 3 minus 4x. Okay, that means it's not that and not that. This one, C, 6. The diagram shows a graph of a continuous probability density function. Nice. Which of the following is the mode? Seems like the mode to me. 0.8. 0.8. 7. Let's go with my answers. Is that a gorilla? How random. Am I losing it? Because my last two answers aren't even correct. HSC. No, I don't. Oh my god, I don't even have the correct solutions. Give me a second. Whoops. There's the correct solutions, not these. Alright, I apologize. I've been like second guessing every single answer that I've had because I had the wrong solutions up. 7 is C, yeah. Oh my god. Idiot. Yeah, I thought this 5 was A. Yeah, 6%. I was sure it was that. But the answers kept saying 30. 4 is D, yeah. 3 is A. Yeah, let me give you that. 1 was B. Yeah, I was sure it was that. And 2 is B. Yeah, okay. Sincerest of apologies. We're good now. What are we up to? Oh my. Okay. We're good. Can't see people's names. 4 people. Sweet. The graphs show the future values over time invested at 3 different rates of compound interest. Which of the following correctly identifies each graph? Jesus Christ. W, X, and Y. Alright. 5% compounding annually, 10% compounding annually. Okay. This is basically saying that this should go up faster than this because it's compounding more. No, sorry. Yeah, it's compounding a higher amount. So this should be higher than W. Is that correct? No. Okay. What have I got? I've got W and X. W and X must be the annual ones because they're quite similar. Is that right? Actually, no. Okay, I think the 5% is this bottom one down here. Y. So that leaves me with C and D. My line of thinking is this 10%, it does change it, but remember that example we did in class where it changed it a little bit? I think that's my line of thinking. So I'm thinking that's why. It's just a matter of whether which one's which. So if this is compounding more often, that would be slightly higher. So that means W should be the quarterly one. W should be the quarter. Okay, so I think it's C. Is that right? 8. C, yeah. Okay, the scores on an exam are normally distributed with a mean of 70 and a standard deviation of 6. So you just score on the exam between the lower and the upper quartiles of the scores. Which shaded region most accurately represents where your score lies? Okay. What's the percentages again? It's 34. Okay, so that's 34. That's minus 34. A quartile needs to be 25, so it's in there somewhere. It's got to be this one, A. Yeah. Okay, my line of thinking was this is 34%. That's 34%. A quartile's got a quarter of it, so 25. So I'm looking for 25%, so that's in there. Alright. What's the derivative of this? Damn it, I need my reference sheet again. It's this one here. So that is equal to, where's the line? There it is. Is equal to f dash x. Okay, so that's f dash x is, oh, what the hell, x to the power of x. What? X to the power of x? V where'd it go? This one. So x is just x. Should that be f dash x? I'm leaning towards this one. Where'd I go? Okay, this. F of x is x. I feel like there should be an x here. I'm sorry, I've used the product rule. This is this. So I've got the derivative of x, which is 1. So that, log of 7, and then f of x. F of x should be just x. I'm really good at finding derivative. Yeah. 8. B. You reckon B? I'm pretty. It's this, but it should have an x on it. That's my. You're guessing C. B. Hello. Alright, what's the answer? D. It is this, but I feel like there should be an X. Okay. Look, I didn't know how to deal with that, so I brought this X out the front. And then I used the product rule. Do we rule from alpha it? Is that? Look, if wolf from alpha denies me, log 7 of x to the third derivative. Try reversing it. What do you mean? Oh, is that why you're saying? So then it's, whoops. Oh, that's so close to that. What do we get? Have a log. What the hell? Well, now I'm more confused. Hey, Sophie. Give me a step by step. No! They changed the base first. Is that what they've done? They divided by log. Alright, wasting too much time. I don't know. I feel like there should be an X there. I don't. Oh. Okay, that's multiple choice done. How long did that take? 15 minutes? 10, well, yeah, 15 minutes. And I was talking through it. Not bad. That's how long you should take. If you take longer than 15 minutes, move on. Alright, find the equation of the tangent to the curve. Simple. F dash x is 3x squared at that point. So f dash 1, 3 times 1 squared equals 3. Alright. Oh, that's a gradient. Oh, the equation. Right. Okay. Y equals mx plus c. 2 equals 3, 1 plus c. Minus 1 equals c. Therefore, y equals 3x minus 1. Is that it? Yeah. Oh, they put in general form. Who cares? This diagram shows a triangle with side lengths x, 11 and 13, angle of 80. Cosine rule. 2 sig fig, 3 marks. Okay. C squared equals a squared plus b squared minus 2a3 equals c. That's on your reference sheet. Okay, C, A, B, x squared equals. Look, I used that computer one that I had before, but that's going to take ages to type this in. I'm in degrees, yeah. Oh, 2 significant figures. Alright. Oh, my rounding. Sweet. This page has been pretty easy so far. Uh-oh. Credit card requires a 4-digit personal email. Personal purchases. Repetition is allowed. Oh, this is probability, is it? Credit card is lost and the finder tries to guess the PIN. What's the probability that the 4 digits entered are the correct PIN? I feel like this is an extension 1 question. Alright, well basically this is how I'd work this out in extension 1. Would be like, alright, well it's got to be a 4-digit PIN. How many numbers can I put here? Well, there's 10 of them. And because I'm allowed to repeat the numbers, I also have 10 here, and 10 here, and 10 here. So therefore, the total amount of pins that I can enter is this. The probability is going to be 1 over that. Am I right? Yeah. It'd be like 10, to answer you, it'd be like 10 minus all the spaces I don't have, 6. Wouldn't be factorial because I've got repetition. Okay, what's the probability that the finder will guess at least 1 digit in its correct position? Jesus. At least 1. Yeah, right. Whenever you've got an at least question, it's way easier to kind of do the opposite. So at least 1 is the same as saying, well, you just got to think of what the opposite of at least 1 is, which is 1. Oh no, nothing. Wait, at least one. So at least one means they could get this one, or they could get these two, or they could get all three, or they could get all of them. The opposite of that is that they, I feel like I said they don't get any. No, it's that they get them all. I guess at least one. That they're all 9 times 9 times 9. Why'd you say 9? Then you take that away from the first answer. That makes sense. Wait, not 1 minus. Nice. Oh, it's a probability. So over 10 to the 4th, because that's my sample space. Nice. Wow, we just got all combinatorics in that. I feel like that's a very mean advanced question. I do feel like that's a mean advanced question, considering it's only 1 mark as well. But thank you for helping me with that. I was a little bit confused. All right. 5 people. Nerd. Hello, C. I'm sure that's Chloe. Alright. Find the stationary points and determine their nature. Look, our favorite question. Whoops. And a full page of working. Isn't that nice? 4 marks. This should take like 6.5 minutes. I guarantee it won't. Stationary points and determine their nature. Easy. First derivative. Not easy. 36 x minus 4x cubed. I set that equal to 0. I've got x's, so I factorize. I can also factorize a 4 out. 9 minus x squared equals 0. So x can equal 0, and then 9 minus x squared equals 0, which means x squared equals 9, which means x equals plus or minus 3. I should have gotten at least some of the marks. They're my stationary points. Okay, determine their nature. God damn it. Okay, x equals 0. Actually, let's move that. So I'm going to do the second derivative test on each of these. Any suggestions so far? Just a smiley face? Alright, well, what happens when I chuck? Actually, let's just. Whoops. If I put a 0 into here, I'm just going to get 36. Okay, that's pretty sure that's bigger than 0. If it's bigger than 0, it's okay, but so there's a minimum. Dash of 3. Now, if there was a 3 in here, that would be 9 times 12, which is a big number. Okay, so that means it's going to be negative. Therefore, a max. That's going to be the same because a minus is going to get cancelled by a square. It's going to be also less than 0. How nice is this question? It's not even making me draw it. Imagine I had to do that. No, that'd be a nice question. Alright, find the stationary points, determine their nature. That's it. Done. Was that it? Yeah, that's it. Except, okay, I have made one mistake, and it's the stationary points, and I've only found stationary x values. So, okay, let's do 30, no, 18x squared.
But you can't tell me what it feels like to wake up next to a woman
Minus?
and feel truly happy. Knowing someone that could level you with her eyes.
Damn it. Actually, the good thing about this is because is that a square? Yeah. Because that's a square and that's a 4, that means I don't have to do this twice, because that's also going to equal f of minus 3. So then max at
You don't know about real loss. Because it only occurs when you love something you won't let
I
go.
hope that's correct.
And don't you ever dare to love anybody more.
Yep. Sweet. 6 viewers, that's the record so far. Sheet covering the screen. Oh, was that ages ago? Whoops. That didn't take 6.5 minutes, surely. Alright, sketch sketch the curve. Damn it. Labeling the stationary points and axes and steps. Alright. If you looked at this and then you were like, oh, hang on a minute, I couldn't answer any of this, just make stuff up, like make up. You know that it's a quartic, which means that it's got one less amount of turns, so just make up 3 points and call them stationary points and try and sketch it. But I've got mine. Would I have a max? Was it 381 and minus 381? And then I had a min at the origin. Okay, the reason I didn't test for point, I could find points of inflections, but they're not going to be turning points of inflection, so that's why I haven't looked for them. It hasn't asked me to do that, so that's fine. Oh, the axis intercept, that's a bit annoying. Yeah, okay. Let's do that. Y-intercept. That means x equals 0. So, what is it? 18x squared. 18. Oh, I know it cuts at the origin. Oh, that is the y-intercept. Idiot. X-intercept. Y equals 0. 0 equals 18x squared minus x. Okay, factorize ax squared out. 18 minus x squared. X either equals 0 or x equals plus or minus the square root of 18. Do that in one step. How does it got through? It's got 3 x-intercepts. How interesting. Alright, let's start sketching. The max at 381. 381. So max means it looks like that. And minus 381. So minus 381 would be like the same point on this side. And now it looks weird. Minimum at 0. And it cuts at, okay, well this, whoops, this would be root 18, and this would be minus root 18. So therefore my graph looks like this. Now, it's not an issue that it's symmetric over the y-axis because you can see from my equation that it's even, so that's nice. Alright. Cool. Guess we need to name it. What's its name? Y equals 18x squared minus x to the 4th. Let me just check that my graph looks sufficient to the picture. It does. Ah, they wrote it as 3 root 2. Root 18 is fine. Let's try some arrows on here. Alright. 2 teams play a game. There are only 2 possible ways to score points. Hitting the red target or hitting the blue target. Hitting the red target scores R points, hitting the blue target scores B points. The results of the game are shown. Okay. I know this is everyone's favourite question. Find the values of R and B. Okay. Alright. Team 1 equals 7 red plus 6 blue, which equals 47. Team 2 is 5R plus 11B equals 47. Call this 1, call this 2. Let's do... God damn. Some nice numbers would be nice. I don't know, this is going to be ugly. Why can't there be nice numbers? Oh, okay, let's... Oh, these numbers are going to be huge. Screw it. Let's go 1 times 5 and 2 times 7. So I'm going to collate, I'm going to make these R values the same. So then this will be 3 and 4. So it's going to be 35R plus, times it by 5, 30B. We can't have nice things. I need to label the origin. Damn it. Thank you. No, David, we can't have nice things. Look at these numbers. Okay. 47 times 5. 275. And I'm timesing this by 7. Okay. I'm going to do 4 minus 3, so I end up with all these positives. That's nothing. Oh, B. 77 minus 30. 47. Oh. Is that a coincidence? 329 minus 235. 124. No way this is the right answer.
They all know what, but understand.
That's irrational. How can... God damn it. Oh my god, the note did exactly what I did. How funny is that? 94. Oh my god, I wrote 359. 94. Okay. What do I want to put it in? 1, I guess. Well, I don't like that I'm ending up with a negative here. Idiot. that's 94. That's 2. That's 2. Okay, we got there. R equals 5, B equals 2. Nice, yeah, that's right. So, oh, I missed one. Holy moly. Differentiate e to the power of sine. What mark is this? 2. Okay, that's fine. You know what that means? Reference sheet. E to the, okay, it's this one here. You see that? Yeah. It's, what is it? F dash x. E to the fx. I really should have known that. Alright, the derivative of sine pi x. Okay. Is equal to. So the pi comes out. Pi comes out. Okay, so it's a derivative of that, and then the derivative of sine is cos, and then this stays. Okay, so that means the derivative of e to the sine pi x is equal to the derivative of the function, which is this, e, top stays the same. Is that right? Yeah. Yeah, that was nice, David. Six viewers, sweet. Alright, given the function and that sketch, oh Jesus. Okay. Remember this, f of g of x. Okay, so f of x, I like writing it like this. F of x is this. F of g of x is g of x squared plus 2, which is the square root of x minus 6 squared plus 2, which equals x minus 6 plus 2, which equals x minus 4, which I'm fairly sure is just a straight line. This is a trick question. I'll show you in a sec. I'm almost certain this is a trick question. Because it says it's natural domain, that means I can't have this be negative. So in other words, this x minus 6 can't be less than 0, which means x can't be less than 6. Okay, x minus 4 is a straight line. That's okay, so it's got a that but down at 4, so that's minus 4. So it's basically this until minus 6, then it stops, and it can equal 0, so I'll put a dot, a closed circle, and this goes on forever. I bet you that's the answer. God damn it, I can't solve an equation properly. X is less than 6, not minus 6. What am I on about? That's there. That can all go. So it's there. I guess we should find out what point that is. So that's the point. Y equals 6. So that's 6 equals x minus 4. That means x is equal to 10. So that must be the point. 10, 6. Is that right? No. Oh my god. X can't be 6. What is wrong with me? X is 6. God's sakes. It's gotta go away. must be so frustrating to watch, I apologize. If x is 6, then y is 2. Okay, that's 2. That's the 0.62. Well, we got there. It was a trick question and it tricked the hell out of me. Okay. Is that? Yeah, that's right. Okay. That was embarrassing. Apologies. Okay. We're almost an hour in. How many questions are there? 71 pages. Oh no, there's answers attached to this. I was going to say. Alright, the diagram shows a continuous function defined. It's defining the function -2 to 10. -2 to 10 consists of a quarter of a circle. So that must be this. Centered at 0, 0. Okay, so that's a circle. Radius 2. Yeah, that makes sense. Straight line segment, which must be this. And the logarithmic function that. Find the exact area. Oh my god. Find the exact area bounded by the function that and that domain. So where's that? -2, 3. That's here. I'm looking for this. Let me highlight it. Okay. Okay, there's a creative way of doing this, and it's well, I guess it's two ways. Finding the area bounded by the curve, you can use integration, but what you got to realize is because it's underneath the x-axis, you'll have to take an absolute value. But this is just, if you didn't know calculus, then 39 pages will crash. Thanks. If you didn't know calculus, then I feel like a Year 10 student would be better equipped to do this than you, because your mind immediately here would go to integration, whereas this is just a couple of shapes. So let's call this area 1. Let's call this area 2. Area 1 is a quarter. It's a quarter of pi r squared, which is a quarter pi 2 squared, which is 4 on 4 pi, which is pi. Area 2 is a triangle. Is half BH, which is half, I'm going to call this the base, so that's 2, height 3, so the height perpendicular is that, which is half of 6, which is 3. So area equals 3 plus pi, surely. Yep. Unit squared. Alright. 6 viewers still. Nice. Hence find the exact value of hence, given that what does it say hence? Given that this that, oh, okay. So between here and okay. Kind of. Between 3 and 10. Alright. It told me that the area between here and here, which is this plus this, is that. But it wants me to find just this, which is this. So in other words, I think given the whole thing, I just worked this out. So I'm just going to do the whole thing minus what I worked out. Whole equals 8 minus 8 minus 10 minus pi. Line was what? 3 plus pi. Therefore, 3, 10 ln x minus 2 dx is equal to 8 minus 10 minus pi minus 3 plus pi, which equals 8 ln 8 minus 10 minus 3 minus 13 minus pi minus 2 pi. Is that it? That's not it. Why is that going to do it? it's not asking for area. You got me. It hasn't asked for area, it's just asked for the value of this. And it's told me the value of all of that. Damn it. Okay, that sucks. That's fine. My watch is telling me I need to go for a walk. Probably, but you know, get what you get. Alright, so it's basically saying, I'm going to split this up. Okay, let me just start writing things. Alright, now this whole thing is going to be this minus this because it's upside down, if that makes any sense. So it's kind of like the integral from -2 to 10. From 2 to -2, the whole thing. Yeah. Bugger off. Okay. This whole area is this. Take away this. Yeah, so it's like this plus the negative version of this, which is like this minus this. That's my new thinking. Okay. Okay. So now I can basically rearrange this. I don't know what this is, that's what I'm trying to figure out, but I know what this is, so I'm going to move him over there. So, plus 3 plus 5. Okay. Let's get messy. Left-hand side is this thing, which is 8 ln 8 minus 10 minus pi plus 3 plus pi. There you go. 8 ln 8 minus 7. Is that the answer? Yeah. Sweet. We got there. It tricked me. Expect to get tricked. Okay. 4 viewers. Oh, bored people. A discrete random variable x has the probability distribution table shown. By finding the value of m, calculate the expected value and the variance of x. Okay, that should be fine. Alright, well, these need to add up to 1. So that's 2 plus 3, which is 5. That's 0.9 plus m equals 1. That means m is 0.1. Okay. Now I find the expected value. So the expected value of x is x p of x, which means, oh, it's a sum. It's a sum of all those. So which means I go that times that, plus that times that, plus that times that, plus that times that. So 11, 0.2, plus 12, 0.3, plus 13, 0.1, 14, 0.4. Thank you. Have a nice walk. Okay, the variance. Variance, now that's e x squared. This is on your reference sheet. So that's basically 11. So okay, so it's all of this, but these are all squared. 1 squared 0.2. Squared. Okay, and then minus EX squared, but I found EX, it's that. So minus 12.7 squared. Sweet. Those should be easy marks. It's just about typing into the calculator, but make sure you write that. A student was asked to differentiate this from first principles. Student began... Oh, good. The student began by writing the formula. Thank you so much. Okay. Jesus. So I'm basically putting this into there. Which means at some stage I'm going to have to expand all this, which is infuriating. Oh, man. Okay. If you're ever left with the inability to cancel out ages, you've done something wrong. It's cool, so you can check your answer. I'm pretty sure I know what the derivative of this is. It's 2x plus 4. Did I get that? Yeah, I did. Alright. Good luck eating. Alright. Diagram shows the different distances of 4 towns. The true bearing also shown. The area of the acute angle. Okay. Calculate the true bearing of town C from. Okay. So from O, true bearing of C. So that's that angle there. So I'm after this angle here. Well, I know that this is. Let's use a different color. I know that that's 29. I know that. Actually, I know that this is 125. How many marks is this? 3. How does the area help me? Okay. Alright. Let's call this T. area of T is, what's that equation? Half AB sine C. That's the area of a triangle formula. I know the area is 198, half, so this is A and that's B. So 25, 16 sine C. 396 equals 25 times 16 sine C. Do it like that. I've got -4. It's not possible. Sine can't equal -4. Ooh, this will be nice. Right, 81.89. Is that right? Cool. Okay, that means that 81.89, which means theta equals 125 plus 81.89, which is equal to 206.89. All right, nearest degree. Cool. How fun are bearings questions? I guess you just need to look at the clues. Like if it's given you the area, like I was just trying to think, like, how am I going to get this angle? Well, I need the area. Well, I have the area, so maybe I'll use the area of triangle formula as a starting point. That's on your reference sheet, by the way. Okay. A small business makes and sells birdhouses. The x-axis displays the number of birdhouses. What? So that's cost. It's the number of houses. Right, how many birds need to be sold to break even? So the break even point is always this. So the number of birds is this, so 20. Look, a 1 mark question, that should take a minute and a half. It took me a minute and a half to read that. By forming the first equations for cost and revenue, first forming, determine how many birdhouses need to be sold and a profit of $1,900. Alright. So it wants 3 things. It wants this equation, and then me to answer this. So that's where your 3 marks are going to come from. Okay, let's do the cost one. So C is equal to, now this cuts through the origin. So I'm going to call the number of birdhouses B. I'll call that B. So it's N or M. Yeah, okay. MB, which is, I basically need 2 points on the graph. What have I got? What's the easiest one? Is it this one? So 10 and, what's that going to be, 400. So rise over run, the rise is 400, the run is 10, which is 40b. So C equals 40b, that's my first equation. R is going to be gradient, and the y-intercept is 500, so plus 500. Alright, I'm going to use this point here. So my rise is 300 and my run is 20. Rise is 300, run is 20. So that's, is it 15? Yeah. 15b plus 500. Alright, a profit is my revenue minus my cost. So profit is revenue minus cost. A clever thing to do here is, instead of having to substitute twice, just make one equation for profit. So revenue is 15b minus 500, and cost is 40b. So that's 15 minus 40, which is minus 25, minus 500. That's a plus. I don't know why I wrote a minus there. That's a plus. Okay. So the profit when profit of 1900. Profit of 1900 minus 25b plus 500. So that's going to be 1400. Which minus 25b. Why do I have a minus? I don't like this. Yeah. Oh, have I got these the wrong way around? Oh my god. Yeah, right. God damn it. "96 birdhouses." Okay. I'm making a lot of mistakes. I don't like this. Alright, if the this function's given, if the derivative of this... this is a cool question. So it's basically told you what the derivative is. And there's clues in here, because it's like, if I've ended up with two things and I'm starting with one thing, then I'm probably going to need to split this up to begin with. So, I know that I know that tan squared is equal to, is it 1 plus sec squared x? Something like that. I always go, so sine squared plus cos squared equals 1. And then if you divide each of these, how do I get secant? It's secant 1 on cos or 1 on sine. It's 1 on cos. So I'll divide them all by cos squared, cos squared, cos squared. That gives me tan squared plus 1 is sec squared. That means tan squared equals sec squared minus 1. So that's close. Alright. So I'm going to swap one of these for this. So I'm going to go tan x, tan squared x, tan x, sec squared x minus 1, tan x, maybe I needed. Have I overthought this? Oh. Goodbye, everybody. I'm not feeling lonely. I've got 3 people in here, all good. My applications, nice. All good. Okay, just looking at that, I have overthought it. So I've got, let me just straight up differentiate this. So tan x cubed, the derivative of that is going to be 3 tan x times the derivative, which is that right? Yeah, which is 6 squared. Oh, I did need this. Okay. Lucky. Okay, that's 3 tan x tan. Yeah, okay. Drop that over and then lower it, so it's 2. Alright, there we go. We got there. Alright. The function is transformed, and the equation of the new function is of this form. I love these questions. Jokes. All right. What's happened? Well, just going to think about what each thing happened. So, like this is a scale. That moves it. So. Minus b goes this way, so that's moving it to the left, and that moves it up, slash down. So that means that my scale, so that means it goes up by 1s, but this is going up by, I'm just looking at rise over run, 3s. It's also upside down, so it's been scaled by -3. It's gone left 2, so this is 2. And it's gone down 1, so that's -1. Okay, so k is -3, b is 2, and c is -1. Alright? Yep. Okay, circle. Oh, these questions are so standard. Move everything and complete the square. So x squared plus 4x plus y squared minus 10y equals -16. So you halve it, square it. Halve it, square it, plus 16. Minus 16. Oh, no, 8. Plus 8. plus y squared minus 10y. Halve it, 5 squared plus 25. I'm going to do that to both sides. Now this is x plus. Why don't I put an 8 down? 4. 2 squared plus. There's all this junk. Minus 6. 13. Right. Find the center of the radius. The radius is root 13. The center is minus 2. Is that right? Yes. Okay. By drawing graphs on the number plane, determine how many solutions there are to this equation. Alright, so it wants a graphical solution because a normal solution is like pretty much not possible. This is like one of those transcendental equations that you can't actually solve. Okay, so I'm basically going to draw this, and then I'll draw this. Now sine x looks like, I always stuff these up. Sine starts from here, goes like that. Obviously, we can draw that nicer. X over 5, the absolute value of that. So x over 5 would be, oh, it just wants the amount, how many solutions there are. So it's even say, well, it's an easy question. Okay, well, so that's like y equals sine x. This is like y equals x on 5, which, okay, x, so that's like 5th x, which is this but lower. I can see why this is a hard question, a little bit harder. I'm going to draw like a 5th. So it's going to be like right like this, rise over run 5. So I rise 1, run 5. So my first point is going to be here. Down 1, and the opposite is true. 1, 2, 3, 4, 5, yeah. Okay, so it's going to have solutions here, here, there, there. Oh, is that a solution? It would touch that, so it is a solution, yeah. Therefore, 1, 2, 3, 4, 5 solutions. Oh, that's tricked me, because that's not 5, is it? What's 2 pi? That's about 6. So the point's actually going to be here. Damn. So that's there. Not there. That's tricking me because I thought these went up by 1, but they don't. They go up by 2 pi. So this is like approximately 6.2. So maybe 5 sits there. This one didn't matter because it wasn't touching anything. Okay. That's transformed. Describe in words how both the amplitude and the period change in this transformation. Okay. So this basically says it does its thing between 0 and 2 pi twice. So normally it's like this or whatever. Now it's going to be like that. So the period doubles. And the amplitude triples. The graph of a function is shown. It has an asymptote y equals 2. Oh, okay. Period actually halves because so between 0 and 2 pi. Yeah, so it does its thing twice, but the new period is this, which is half. Sorry. Alright, the graph of a function is shown has an asymptote at y equals 2. Using interval notation, state the domain and range. Okay, that should be easy. Okay, if it has an asymptote at y equals 2, that means it's not touching there. So, okay, its domain, that's the x values, is, what's interval notation? That sucks. Okay, so it starts here and then stops here, so that's 1. So it's between, so this is my x values. My x values minus 1 and 0. It goes between minus 1 and 0. Okay, and between 0, I've used open brackets because it doesn't touch, and then it goes on to infinity forever. The range is the y values, and that goes from, so negative 2 to 2, so negative 2 to 2, and also negative 2 to 4. Okay. Square brackets because they're touching, open brackets because there's an asymptote. I don't agree with the solutions on this one. The solution reckons it goes from here to here, but that's not true because it cuts there. Yeah, dumb solutions. Okay, let x denote a normal random variable. Oh, dog. Okay, so this is basically the equation of a normal distribution, and you never really have to use it unless, of course, you're told to. All right. Now, let's see what values. Okay, so it's done a bit for me. It's basically saying that this is this, so it doesn't actually touch, must be a little bit lower. 0.24, 0.24 is probably there, and that's 1, yeah. So 2, I'm looking for something, it's probably about 0.05. It's good to know where your solution kind of is. Okay, so I'm using this. So I'm looking for f of 2, so f of 2, is it giving me lines of working? No. Okay, f of 2 is 1 on root 2 pi e to the minus 2 squared on 2. It's good not to get overwhelmed by such a disgusting equation. So we're just going to type all that in. 1 square root of 2. E fraction minus 2 squared. Gave me 0.0539, and that's what I wanted. I wanted it to be near that. Okay, just make sure it checks out, like 0.05. That looks around right. Alright, use the trapezoid order rule and the 4 function values in the table to show that this. Okay. So 4 function values. Okay, let's get the trapezoidal rule. Where's the trapezoidal rule? There it is. Okay. Where'd it go? There. I'm just writing it down so I can fill it in. So B, A is minus 3, B is, okay. So it's 3 minus 3 on 2, and it's the amount of things I've got. Oh, okay, that's clever. That's symmetrical. This is cool. This is verifying that 3 standard deviations away is 0.99. That's a cool question. What I'm going to have to do also is, this is only going to give me, if I'm only using these values, it's going to give me this area. So I'm actually going to have to double this. There's quite a lot involved in this question. So it's going to be this plus this plus this plus this. So that'll be A and that'll be B. So it's actually going from 0 to 3. And I'm going to, yeah, okay, 1, 2, 3, 4, 2 times 4. F of A, 0.3989. F of B is this, 0.004432, plus 2 times the ones in between, 0.2428. Okay. Do I want to sit there and type that in? Screw it. Should be strip width, should be 1 or 2. Let's double my answer. Cool. Now I don't like the way they write it with the B minus A on 2n. I just like doing the strip width, which is the difference between these two, over 2. That's much better. Okay. A few questions, eh? Whoops. Okay, IQ, the intelligence quotient. Scores for a large population are normally distributed with a mean of 100 and a standard deviation of 15. Use the result obtained in part B. Calculate the probability of randomly selecting a person with an IQ score above 145 from this large population. Interesting. Okay. I like drawing it. So I'm going to go... so the mean's 100. Standard deviation of 15. It's going to be 1. That's going to be 85. 145. Oh, jeez. Okay. So that means it's 3 standard deviations away. Therefore, the probability is going to be, so the probability will be, we're looking for this little section here. Now we know that all of this was, okay, so it's the probability. This 0.497. Okay, it's basically, let's go. 0.99. Minus, let's call this in there x, and let's call that x, minus 2x. Don't ask me for a percent, please. Calculate the probability. Okay. That's 0.235%. Alright, looks like I'm just chilling by myself. All good. Alright, population P of rabbits on an island is given by... Okay. Alright, so I basically want P. I want to know the population of rabbits, or the amount. Now I'm given the derivative, so I'm going to have to go P equal to the integral to 5T. Okay, so equal to 30 e to the 1.25 t 30 times divide by the derivative, so 1 e to c. Okay. This is a sucky question because it doesn't give you any initial conditions. So basically what you can do is you can say that, well, I want to know what happens after 10 years. So tell me the integral from no years to 10 years. That removes my need for a plus c. 0 to 10. So I can go like this. From 0 to 10. Now that's 1.25 e to the 1.25 times 10 minus e to the 0 t. No, 0. 24 e to the 12.5 minus 1. Two significant figures. Okay. 3 marks for that, really? Yeah, right. I'm going to smash this time. How many questions are there? Maybe not. Holy moly. Okay. Alright. A bid made at an auction for a real estate property in millions of dollars can be modeled by the random variable x with the probability density function. Okay. Show that the value of k is 1 on 27. Yeah, right. So in other words, the integral of this should be 1 between these two. So the integral between 1 and 4. No, that's right. Oh, the Beta Bay raised $62,000. That's a cool email. Okay. 16 minus x squared. At least it's giving me the answer, that's nice. This k can come out front. The integral of this is going to be 16x minus raised to divide by 1 on 3x cubed between 1 and 4. This has got to be equal to 1. Okay. Now that's what's 16 times 4? 64 minus 1/3. That's 4 cubed. 64. Interesting. Okay. Minus 16 minus 1/3. 1. Wowzers! What's all this stuff? 64 minus 1/3, 64. 4 minus 64 and 3. Okay. Minus 16 plus 1/3. 27. Ah. Easy, 2 marks. Is that it? Cool. Find the cumulative distribution function. Really not the CDF. Okay. K, which is 127. 16 minus x squared. X is in, what was it? 1 and 4. 1 and 4. Okay. light red. Oh, calculate light red. Integral 4, 7, 4. Do it from, is it t to infinity or infinity to t? Is it 1 to t, negative infinity? Oh, you do it from where you start. So it's where you start to, I don't know. That's what I'm trying to figure out. Yeah. 16. Is that an x? Yeah. 1 on 27 can come out. Actually, let's do all this in one step. We did this before. 16x minus 1/3 x cubed. From 1 to t. 1 on 27. That's 16t minus 1/3 t cubed. Minus 16 plus 1/3. Are we happy with that as a final answer? Probably not, eh? 16 plus 1/3. It's only 2 marks. Guess I could times everything by 3. It's 3 on 27. 16 times 3. Okay. That'll do. Okay. Find the probability that a bid of more than $3 million will be made. Excuse me? Oh, should have probably read what the context was. A bid made at an auction for a real estate company can be modeled. Ooh. Okay, so it's in millions of dollars. Okay, so X is the millions of dollars. Cool. So I guess I'm going to use my CDF now. Just make sure it's right. Why do I keep using T? Guess doesn't matter. I've used T for some reason. Yeah, it's right. Except that's. Oh, you idiot. That's 81. And that's a 7. It was very close. Okay. Cool. Now, probability that a bidder more than $3 million. More than $3 million. Okay. Alright. What we've got to realize about this is, so here's my function between 1 and 4, because that's where it's defined, between 1 and 4. Now, pretend it looks like this. More than $3 million, so that's a 3. That means I'm looking for this section here. What this cumulative thing is going to give me is from 1 to t. So from 1 to 3. So I'm going to have to find the integral from 1 to, well, I'm going to have to find f of 3. So f of 3 is going to give me all this. So I actually have to do 1 minus that. Okay, so 1 minus 1 on 81. 8 times 3. And that's going to be equal to farmer wishes to make a rectangular enclosure of 720 meters squared. To use as an existing straight boundary as one side of the enclosure. This is going to be a maximum minimum question, isn't it? She uses wire fencing for the remaining 3 sides, and also to divide the enclosure into 4 equal. Okay, the total length is L. Total length of wire. Wow. Okay, so this is basically X, 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 X. 1, 2, 4. Okay, that's that. So we're just going to prove that this length is this. So we're basically saying that 720 is that. On the minimum length of the wire, that's required, showing why this is a minimum length. Okay, cool. So the minimum length of the wire. Here's the length of the wire. Let's prove that this has a minimum. How am I going to do that? Well, I'm going to differentiate it. dl on dx is 5 plus. Did I quotient rule that? No, that's 720 times x to the minus 1. I drop it, so minus 2. Okay, so 720. Drop it, minus 2. No, minus 1. X to the minus 2. I feel like I haven't differentiated something like that in ages. Minus 1, minus 2. Okay. It's equal to 5 plus minus 720. X to the minus 2. Okay. That's 5 minus 7. 720 on x squared. Okay. Find the minimum. Set that equal to 0. So that's 5 equals 720 x squared. 5x squared equals 720. X squared equals 134. Nice. X equals plus or minus 12. That equals 12. Take the positive because it's a length of wire. Okay, so yeah. Okay, now that's my stationary point. Now I've got to prove that that stationary point is a minimum. The way that I do that is with the second derivative, so d2l on dx squared. Okay, so let's just look at this. So it's, I drop it, so it's going to be positive 720 times 2. 1440 x to the minus 3. Okay, f dash dash of 12 is, let's rewrite this one, 440 on x cubed. So that's 1440 on 12 cubed, which equals, well, I know that that's going to be positive. That's greater than 0. Therefore, it's like this, so it's a minimum. Done. Find the minimum length of wire. Oh, damn it. Oh, x is, no. Okay, we're almost there. We've found the minimum. Oh, sorry, we found the stationary point. We found the minimum. Found that it's a minimum. I need the length of wire. Well, this is the length of wire formula. So L equals 5x plus 720 on x. Okay, I found the minimum x value, so let's substitute that. It's 5, so L of 20 is 5 times, sorry, 12. We're on a roll, people. That's 60 plus 60, 120. Sweet, minimum length of wire, 120. Done. Alright, particles moving along the x-axis. The graph shows its velocity. Okay, well, so it's slowing down. When t equals 0, the displacement is equal to 2 meters. Okay, so it's 2 meters away from the origin when it starts. On the axes below, draw a graph that shows the particle's displacement x meters from the origin at time t seconds between t equals 0 and t equals 4. Okay. Now t equals 0, it wants its displacement well, at time 0, so here, its displacement is 2 meters. So that's where it starts. It starts there. And at t equals 4, okay. At time 4, look at this, at time 4 it's got no velocity. At time 4 it stops. Okay. Rise, beta, run. -2, the gradient's -2. It's basically a straight line, right? So y equals -2x plus 8. Okay. I can integrate that. So, can I go capital Y? Is raise it to divide by it, so -1x squared, so 8x. Y of 4. I guess -16 plus 16. Right. Oh, I didn't. Okay. Plus C. Xena would kill me. Also, this is V and T, so this is actually displacement with respect to time. And I know at time 2, at time 0, the displacement's 2, so I know that 2 equals 0 plus 0 plus C, so C equals 2. Oh, I've got lines for this. So the displacement is -x squared plus 8, no, not x's, t squared plus 8t plus 2. The displacement is actually an x. It's working out disgusting. Right, so x at time 4 is going to be -16 plus 32 plus 2. 16 plus 2, 18. Let's call this 18. We got there. Is that right? I suppose I should curve this. Doesn't really matter. Alright. The table shows the future values of an annually. Oh, how fun are these questions? Still no viewers, how sad. Okay. Table shows the future values of an annuity for $1. So this is what I was saying, where they actually have to give you the table. This is all just telling you that this exists. An annuity is opened and $2,000 contributions are made at the end of each year for 7 years. For the first 6 years, this is the interest rate. For the 7th year, it increases. Calculate the amount in the account immediately after the 7th contribution is made. Okay, there's a little bit involved in this. Made at the end of each year. Okay. Cool. How many marks is this? 3. Alright, well I've got a table, so I don't have to do anything manually. That's nice. So, my future value on $1. Okay, so pretend, screw this. I've got 6 years at 4%. So 6 years at 4% is this. 6.633. Okay. Now my future value on $2,000 is equal to $13266. Okay, so that's after 6 years, and then $2,000 gets put in once. Okay. I can't use the table for this next part because it only deals with 4, 5, and 6 years. I am only concerned with 1 year. So this is the 6. So this is 6 years. Now I'm going to do the 7th, which is 1 year. Okay. So the 7th is, I've got $2,000. It compounds at 5%. So 1.05 for 1 year. Oh no, I've got the same amount sitting in the account. So it's the 13266. Okay, so this is what I get in the 7th year. Is that it? Okay. So then a 7th contribution is made. So then add 2,000. That's a clever question. There's a lot involved. I was just thinking 3 marks. I don't know how I've earned 3 marks. So I have to find this future value on 6 years. Then I have to compound all of that for 1 year at a new percent. And then I had to add $2,000 because there was a contribution made straight after that. The diagram shows the curves y equals sine x and y equals root 3 cos x. Find the area of the shaded region. Okay, so I need to know where they intercept. So I'm going to need this point, and I'm going to need this point. So I'm going to have to solve these simultaneously. Y equals sine x. Y equals root 3 cos x. This is a cool question. I'm ahead of myself. 10x equals root 3. Okay. X equals pi on 3. Are we looking in radians or degrees? Radians. Okay. That's pi on 3. That's going to give me that. So the pi on 3 will give me that solution. Okay. Just draw a quick unit circle. of this pi on 3, which is pi plus pi on 3, which is, so that's 4 pi on 3. Okay, so that means now I need to, oh man, this question sucks. The integral between pi on 3 and 4 pi on 3 of, now it's this curve minus this curve. Yeah, right, okay, so sine x minus root 3 cos x dx. I'm doing that right so far. Yeah. Okay. Okay. Derivative, the integral of sine x is negative cos x minus root 3 sine x between pi on 3 and 4 pi on 3. Okay, that's equal to minus, do this one step. Let me just write this properly. I made this when I was in high school. Cos pi on 3 is found. What's that? It's half. Sine pi on 3. That makes 1 plus 3 on 2. It's 1 plus 6 on 2. That's 1 plus 3. Sick. Alright. Ireland initially has 16,100 trees. The number of trees increases by 1% per annum. The people on the island cut down 1,161 trees at the end of each year. Show that the first year there are 1,500 trees remaining. Ooh, just got invited to the movies. Online movies. Okay, the number of trees increases by 1% per annum. 1% per annum. People on the island cut down that at the end of each year. Okay, so this is like compound interest and then minusing. This is kind of like a repayment question, but it's disguised as a tree question. Okay, so 16,100. It increases by 1%, and then there's this much cut down. Alright. Sorry, Charlotte. Oh, I typed it in my calculator wrong. There we go. Alright. Show that at the end of 2 years, the number of trees remaining is given by this expression. Okay. So T2 is going to have, so I'm going to call this T1, that's the amount of trees after the first year. It's going to be this, then another compound, and then 1161 taken out. This is one of those ones where lots of working. Square brackets. This is a show that question, like I was saying the other day. 1.01 minus 1161. Okay, so that is all of this, which is all of this. Compounds, minus 1161. Okay, so this times this is going to put a squared on that. 161.01 squared. This times this is going to be minus 1161, and then there's a minus this on the end. I'll factorize that minus that on the end. So then it's that plus 1. Why did the thing turn blue? Oops. And that's it. That's that. Cool. That was easy. 3 marks. Took me like a minute. Still no viewers. I've been by myself like an hour now. Oh well. Okay, show that at the end of n years, the number of trees remaining is given by that expression. Okay. T2 was equal to what? Let's copy that. That means T3. For a show that, I'd go one step further, I reckon. Actually, I'd also do this. I've got 100,000 there. That's interesting. Anyway, okay, that's T2 compounds. And take away 1161. Oh, I did it again. Okay, I need it to look like this. That's interesting. Let's just fill this out. I kind of want to take the sum of this. That's what I kind of want to do. I want to see what happens. That's my thought. Any other question you do, you'd go, okay, that's a GP. So maybe I'll do that. Right. S of, how many terms are there? There's n of them. A is 1. R is 1.01. N. It's the only way I can think of getting this, like this term here. Minus 1. 1.01 minus 1, that's equal to 1.01 and minus 1, this is 0.01. Let's work with this. just playing around. I have no idea if this is going to work. I'm going to factorize this out. Okay. My mistake was this. I thought I had to times this up because it was like an equation, but it's not. So I'm going to do this divided by this, which gives me 116,100. Okay. Oh, that's where the million comes from. Okay, still going to factorize that. Must be a million, is it? Minus 1,000 or a million? 1,000. Okay, well, how many years will the people on the island be able to cut down that many trees annually? So that would mean when, like, it'd need to be positive. How many years? Okay, so there's going to come a point where this is going to be negative, so there'll be like no trees. So I'm thinking if I set this equal to 0, yeah, I'll set this equal to 0 and solve it for n. I'll write how they wrote it though. So 0 equals 116,100 minus 100,000. Oh, there we go. 15 years. Surely we're close. Oh my god, we're heaps close. How long do I have? 45 minutes? See? No time. Okay, a set of bivariate data is collected. Okay, determine the equation of the least squares regression line. God damn, I'm gonna have to type that into my calculator. Okay. I need that. Give me a decent one. It's 2 variable. 12, 10, 9, 13, 10, 13. 181, 190, 193, 196, 188, 175, 198, 192, 201. AC, shift stat, regression, equation. So the equations y equals a plus bx, a equals 136.04, e equals 4.85, therefore y equals the equation. Did I get that right? Yep. Okay, play with shoe size of 11 was absent when the data was collected. Calculate the predicted using your answer to part. Alright, so that means thought I heard something. Okay. Y equals nice. Cable is freely suspended between 2 10-meter poles. Poles are 100 meters apart and the minimum height of the cable is 8 meters. Height of the cable is given by that thing. Holy moly. Show that the value of C is 4. One mark. Yeah, right. Okay. That's my equation. I'm told that that's a coordinate. No, that's a coordinate. That is the point 0, 8. That's the point 50, 10. That's the point negative 50, 10. Okay. So I'm going to use the 0, 8.8 equals that's 1 plus 1. That was easy. Use the result in part A to show that one value of k is that. Okay. Please paste. That's 4. I need to show that one value of k is 1, 2. Alright. I haven't looked at the solution, but I'm assuming that this minimum is a thing. It's a stationary point. Which means I've got to differentiate this. Are you kidding? Okay. I don't know what k is though. I suppose that doesn't matter. Alright. Derivative is, well, this is 4e to the kx plus 4e to the minus kx. Okay, derivative is 4ke to the kx plus minus is that 0? No, there's a minus there. Okay, now I set that equal to 0. Is that not going to give me that my stationary points? It's going to tell me the only solution to that is 0. I know this. Oh, okay. I know the solution to this. It's no, 0 is where the minimum. It's 0 here. I know there's a minimum of 0, 0. So if that was 0, how do I get the ln 50? Oh, okay. I wasn't on the right track at all. Okay, I thought it might have had something to do with 50. So this 50 in here looks like it's got something to do with this 50. So I'm going to write, actually, let's just go back to this for a sec. I know that the point, the 50, 10, the point 50 10s on here. That means 10 is equal to 4 e to the 50k plus e to the minus 50k. I know that that's a thing. 10 on 4 is 5 on 2. Can't deal with this, so I'm going to let u. I don't want to put u, yeah. I like this question because it involves a substitution that you don't know. I feel like this is an extension question. So that's like 5 on 2 equals u plus u to the minus 1. I really don't think this is an advanced question, eh? 0 equals really don't like this. Then they times everything by u. So then it's u squared plus 1 minus 5 on 2u. I'm going to double everything, that'll get rid of that fraction. So 2u squared minus 5u plus 2. Go in and look at that, that's disgusting. I'm going to factorize that. Yeah, right. Now it's going to be this one, isn't it? That's a disgusting question. Okay, hence, it's the reason it's the last one. Hence, find the area between the poles, the cable, and the ground. Okay. So in other words, that was my function. I'm going to find the integral between this and this. So I'm going to integrate between negative 50 and 50, and it's, well, I don't like that it says hence. Oh, one value for k. Okay. Now, it's this and this are going to go, so I'm going to have 1 on 50x. E dot ln 250 is equal to E ln 2 times 1 on 50, which is E ln 2 Will I ever think of this? How do I get the 50 out of there? How do I get the 50 out of there? Does it just literally become 1 on 25? confused by this 50 on here, so I'm just going to do this manually. This is, I don't have to deal with negatives. It's that because it's symmetrical. So let's bring this 4 out. It's going to be 8. E to the kx plus e to the minus kx. There we go. That's minus e to the minus ln2. Minus e to the ln half We are done. Holy moly. How long did that take? What is the time? 2:08 to 4:43. 4:43. Wow. I am very tired. Okay, so what's that? That's 4 hours 43 minutes minus 2 hours and 8 minutes. That took 2 hours 35 minutes. And you'll notice that I made a gazillion mistakes in there, which is not a bad thing because I would have still had 25 minutes to try and repair all those. I hope when you guys are working through these that might have given you a little bit of confidence, just knowing that mistakes are very easy to make and it's very easy for you to be tricked by some of the questions like I was. Now, I haven't done a past paper in a very long time, and you guys have probably never done a past paper before, so it's kind of cool that we're kind of on the same level at the moment. So in terms of the styles of questions that are being asked, so generally like in the textbook and stuff, you might get questions that are very similar in nature, whereas these were kind of all over the place in that they ask you things like in kind of weird ways, and that can kind of catch you out, and that's what it's done for me. So in other words, the more practice you get at this, the better you're going to be. So the more practice I get at this, hopefully the better I'm going to be. But still having 2 hours and 35 minutes, still having 25 minutes up my sleeve is a good thing, because I would have had to have gone back and had a look at these. Cool. Goodbye.